Hello viewers, welcome back to the channel. Today I'm going to describe how to model a bracket. A bracket is a piece of metal or plastic that connects two or three parts. There are plenty of FreeCAD modeling videos out there where a model is built from start to finish. Now in this video I'm going to take a step back and start conceptualizing the model building process. So, what is this conceptual stage? Let's say you are given a sketch or drawing of a bracket, something like shown here. Now, how do you start this model? Now, as a beginner, this will be a little bit intimidating. So, I'm going to walk you through a simple set of questions quickly to plan the model building process, and then we will start modeling. Do you have multiple 3D features in this bracket? Yes, we got holes, base plate, L bracket, fillets, etc. So then what feature to start with? You got two options here. You could start with L bracket or base plate. It is easier to start with base plate. Typically you start with the most predominant complex feature. What workbench you are going to use here. Since modeling the part workbench primitive to this shape going to be inefficient, use part design workbench. Start with a sketch and pad it. If you're not familiar with the part and part design workbenches, I would recommend watching one of my previous tutorials on this topic. Links will be in the description. A master sketch location. You will need multiple sketches to complete a typical model. This is the first and the main sketch, and we can place the master sketch bottom of the base plate. How to simplify? This is most important thing in model building. How to make it easier for yourself. What you're looking for here is repeated features. It may be holes, fillets, or it could be symmetry. In this example, if you remove this hole, everything is symmetric. So you could model only half of the model and mirror it. Secondary sketches. This model I'm going to model L bracket portion with a second sketch. By placing it in on the base plate, we will create two more sketches to capture the two other holes. Finally, I'm going to dress the model with fillets since it is recommended to do this as the last step to avoid any topological errors. So this is the tech drawing of the model. So if you are given this drawing, how to model this? So based on the questionnaire we went through earlier, our model building plan is shown here. You start with the master sketch and then pad it. Place the second sketch on this face here and pad it to build the L bracket. I call this L bracket here. And then you can create the third sketch to slot this hole. Okay, then you can create this or take this section and mirror it to create the complete model. And finally you have to create a sketch 4 to slot this hole as well. Then you add all the fillets. So the steps are given here. So that's how you plan your model building. So let's start with a new model. I'm going to rename this model. So first thing is to create our master sketch. I'm going to pick the XY plane. So here I'm going to create a center and 2-point circle, or just a half a circle. So this is my initial sketch, and I need to close the sketch. Now, of course, when I close the sketch, I think I have over constrained it. So what you have to do here is go and delete this constraint, because this is not required. So now this sketch is unconstrained. Okay, so there aren't any constraints I have applied. Now what I need to do is to apply some constraints on this sketch. So first thing is I want this to be perpendicular. So go pick perpendicular, pick the first line, pick the second line, and make it perpendicular. Okay, so the next one, I want this line to be 45 degrees to this guy, so I can go to angle constraint and apply this constraint to be 45 degrees, and then we can put more dimensions around this. So still I'm in the angle constraint, so I'm going to escape out of that. Now I want to add some linear constraints. So for this one, I'm going to pick this 2-point distance constraint, pick this point and this point, and I have a specific, I want to make it like 2.7, okay? And now I want to have another length here. So for this one I can use this guy. We'll make it 1.84. Now if you go back to your tech drawing, you'll see this kind of a correspond to that drawing. These dimensions are okay. So we are going to follow the tech drawing when we create these dimensions or the constraints. So next one is to put a radius constraint to this guy. Let's say 1.25. Now it looks like it's too big, but you know, we're going to move this around, and still it is floating, so you can adjust it. Now another thing that is missing here is you want this to be tangential. Okay, so this is the tangential constraint. Pick this guy, pick this guy, that become a tangent. Okay, and same here, this needs to be tangent as well. Now this is so good. Now another constraint radius is this guy. Let's make this guy, let's say, so what was our tech drawing? How much was that? We can take a look at it. It's 2 inches. And we have another hole here, so we can create a hole. This time we want to say pick this guy, and we want to put a dimension around that as well. Going to put a constraint diameter. This way it is easier, because that's what is given in our tech drawing. So it's 0.5. Now there are a few more missing constraints, and I think I know what they are, so we'll go put those constraints as well. One thing that is that needs to be added here is this point to this point, because this is a positioning constraint. So we can use actually 2-point constraint here, and let's make it 1.2 inch, and let's say, so there is one more constraint here. This needs to be perpendicular to this line, okay, my y-axis. So I can put a perpendicular constraint here. Now my sketch is fully constrained, okay. So once you have fully constrained sketch, you can let's say you can close it out. And now what you need to do is, in order to create the base plate, you're going to pad this guy. So I'm already pick on the sketch. I'm going to say pad, and I think the thickness is in our tech drawing is 0.5 inch. So I'm going to say 0.5. So now we completed the base plate. So the next step is to create the second sketch and pad it up, okay. Now easiest way to do that is to pick this surface and create a sketch, but I'm not going to do that because we have in FreeCAD we have this problem called topological error, where the current FreeCAD versions keep track of all these faces and bodies in a numbering scheme, and that can get messed up, and that can cause problems down the road, because if this number changes, whatever that you create on this face get essentially kind of screwed up, and that we want to avoid that, okay. So what the alternate solution for that is to, rather than creating a sketch on this face, create a datum using the original planes and move that to align with this face, okay. So what I'm going to do is activate the origin, and let's pick the XY plane and create a datum on that. Then so go to recompute that. Then you have this attachment scheme, and in that you have this position, and I want to move this plane in vertical direction. Now I have videos talking about all these how to move planes, how to manipulate planes. I will put those links for that videos in the description. You can go and watch them, but here I'm going to go fast and just going to put 0.5 inch, and then this plane is aligned with this face. Now I can use this datum to create my sketch, so I don't need this one. Hide that. Now pick the datum, pick the sketch. Now you got the sketch. Now what you need to do is to, since I want to create my sketch here and I need some reference edges from the solid I already created, you can use this edge linker to get these edges into the sketch. So click on the edge linker, click on this edge and all these three edges. Now all these three edges are part of the sketch, okay. Now you can escape out of that. Now I have to create bunch of lines connecting this. So you got the sketch creator. Now once again this problem came up where there it's over constraining, so I'm going to just delete this last constraint. That will fix it. Now what I need is essentially I need to go back here and put a couple of constraints to make this fully constrained. So I'm going to use parallel constraint, escape out, and give some dimensions to this. So this needs to be 0.3 according to our tech drawing. Now everything is fully constrained. You escape out of it, and now I can pick this sketch and pad it. Now the height of that is 2.2, so it can go and create 2.2. Now so the completely that part is finished. Now you might think that these are two bodies. They are not. Okay, so this is one single body, and this is, if I go and pick on this guy and hide this, you essentially completely remove the body from the visibility. So what that says is this padding operation essentially contains the entire body. So that's the concept of FreeCAD. FreeCAD always, when you use the part design workbench, and even on the part workbench, it kind of put everything into the final operation, all the solid into the final operation, which is, this concept is called the single cumulative solid per one body. Okay, so this is not just one body. Even though we created it separately, they're just joined, fused together. Okay, so far so good. Now let's add this hole here. So as I did previously, we are going to create another datum plane. So in order to create the datum plane, I'm going to activate the origin again, and I don't have an exact plane oriented with respect to this surface, so I need to rotate one and get aligned with that. So that's not as bad as it looks. So let's pick this guy first, which is the XZ plane. And then click on the plane. So you created one, so you already attached that plane to the to this XZ plane. Now I need to rotate it. Now there are several ways you can do that. Now I think this y-axis of this plane is aligned in this direction. Now in reality, you might have to check that one out by moving few things around here, but since I think my guess is right, so I'm going to go ahead and put 45 degrees. So since I want to rotate it about y-axis, so let's see what happens. So yeah, it did rotate it about y-axis, but it rotated in the other direction I want, so I need to go back and put negative sign and enter. Now this plane is not exactly in this phase, but it is over here. Now I can go back and deactivate the origin. Now do I need to all the way align this? Not necessary, because what I'm doing is I'm just putting a circle, and I'm going to use the slot option here to kind of slot through this the solid. Okay, so because of that I don't need to align it all the way, so I can pick this guy and I can start putting a sketch onto that surface. So that surface it's on this face now, this sketch is. Now we can do the same thing as what we did previously. We can get those geometric linking edges and I want to get these edges the other side. Okay, this is the forward side. If I call it the forward side, I want to get it the other side. So what I'm going to do is I'm going to rotate it and I'm going to capture these edges on the back side. Now I think I got all of them captured, so escape it out and rotate it back to the original view. Now I'm going to put a circle. It was okay, let's see, the drawing says it is around 0.6, so I'm going to put constraint diameter to 0.6. so it is constraint 0.6, but it is not around the center. So what I can do is take the symmetric option or the symmetric constraint here, pick this edge, and then the center. It will put this whole symmetric along this two nodes, but it's essentially so everything is symmetric now. Even on this side it is symmetric, so it is fully constrained. I can close it out. Now I have this hole on this datum plane. Next step is to use the slot option here. I'm already selecting the sketch, so go ahead and pick on the slot. Now you might see that I haven't slotted through because the length is not enough. Now what I found is that it is easier to, if you put 2 dimension, because you don't know either which direction it will go, so you put both and see which direction it will slot through, and that will do the trick. Now if you know exactly which direction you want, you can pick one of these options, but this seems to work the easiest. So I'm going to increase until I slot through the solid. So it's completely slot through that. So that's all we need. We just need a slot through that, and we escape out of it. So we put the slot or the hole through the upper L bracket. So far so good. Okay, so now next step is, since we have created the symmetric portion of this model, we can mirror it. So we're going to use this icon here, this button here, to create the mirror image of this solid. Okay, so let's get this guy out of the way. Now what you have to do here is click on this. So these are the essentially all the solids that I created, all the operations I created. So I need to pick all of them. There's the pad, and there are 2 pads, one here, one over here, and then there's a pocket, which is this guy. Okay, so let's pick all of them, and it's pretty much automatically does that. What happens is FreeCAD detect the symmetric plane or the symmetric axis, and it just kind of automatically mirror it. So sometimes you have to manually do it, but in this case it is automatically done, so I don't have to do anything. I'll just close it out and it's complete. So next step is to put this hole here. Okay, so I'm going to use this datum plane to put that hole here. and create a sketch on this datum plane. So I click on this and then go into the sketcher, and all I need to do is to put a circle here, and then escape out of it, put a dimension, say 0.81, and now I need to constrain it to these two edges. Now of course I can, as I did earlier, just pick the geometric linker and pick a little bit difficult to pick that. Okay, so we got that. Now I'm going to rotate this guy here to pick this edge. It picked the entire axis. Let's see if that is correct. Yeah, I can still use that, so that's fine. Now let's say 0.025. Has to be 0.91. Okay, so I got fully constrained. I'm closing out. This hole is already picked. Let's slot this one, and I need to make it through all, so that pretty much gone through that. So that's pretty much it. So we pretty much created the entire model, all the features except for the fillets. Okay, now so I'm going to get this plane out of my way. Now one thing to keep in mind, this is a complete solid. Now if you can see, there's two parts to it. It's divided by this line, but it's one complete solid. As you can see, this is in compliance with the single solid philosophy, single cumulative solid philosophy of the FreeCAD, because this pocket essentially has the entire body wrapped around it. Okay, now the way to get these lines to make disappear is to go to refine here in the property section under data. Just click on this, say true. Okay, this will kind of show. Now you can see that it is one complete solid. Right now, when you fillet it, you might want to do that before you start filleting it. Okay, so what I can do is I can pick this guys, and when you want to pick multiple edges, control pick. It's like anything we do nowadays, and just let's say 100 is, I think that was on the drawing, so just make it 100. And now you can pick these ones. Once again, control pick. Now it pretty much put everything around as anything that is continuous. It captured everything, so that's what we want. But go ahead and do that. Maybe even we can pick separately these holes, edges, and start filleting them as well. Okay, so you can do this. This is not a big deal. You can, if there is anything left, you can just pick them and just start filleting them. Okay, so we kind of come to the end of this solid. I hope this tutorial was very useful for you guys, and I do appreciate your comments and questions on this regard, and then also please leave any questions or comments in the comment section. Would appreciate your subscription. The subscription is free to this channel, as you always know, and look forward into the next tutorial.